Casini. Funziona? Hello, 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 hello. Good morning. Good morning, everyone. Are you connected from the cloud?
Yes.
Okay, yes. So Prashant is hearing us. So I think that some people are late, so we'll be waiting a couple of minutes so that we hear him, because I don't know how many people are connected. Prashant, probably you may take a look at. So how many people are connected there? Exactly.
Adani.
You can look. Ciao Nuno. You can look around the cloud. And so, okay, I'm gonna check it out. There is always the dangerous thing that if you open one wrong file, then I'm gonna release classified information, which is something that I would like to avoid. But that's okay. Yeah, waiting. So maybe some things crashed. Cool. Okay. So we'll be waiting, let's say, another 5 minutes just for people to arrive and connect. So, because actually, I don't know, my Teams is not working out. So I don't know how many people are connected. Force quit. Microsoft Teams. No, that's weird. It should be. Sometimes this team. Ah, è là. No. Porca miseria. Okay. So I'm trying to organize coffee breaks. Coffee breaks for the next. Yes, crowds. Okay. So hi guys. Let's wait a couple of minutes. That yes, coffee breaks would be really nice to have here. You know that IIT is this particular place where you can buy jet turbines, but you cannot buy 20 bucks of cakes. So it's always it's a little bit, but they have their own reasons, which are also reasonable. So it's always difficult to somehow find a trade-off. So Prash, how's going the cloud situation? Now cloud
We,
Prashant is our reference point to the cloud.
I'm the
Huh?
weatherman today. So we are Adi, Andrea, Nuno. Uh,
Okay, so there are also other people arriving. Huh? Yes, now I think that we have 6, 7 time zones around the world. People are connected in the cloud, and yeah, I think that after this, we can start. Yeah, probably people find my presentation annoying, so they come late on purpose. But that would be reasonable also. So, okay, let's get started. Okay, so hello everyone. Welcome to the research increment number 10, 7 minutes later. So for the newcomers, what we do is that we meet every 3 months and we review what we did in the last 3 months, and then we basically plan the next 3 months. What usually we do is then people working specifically on joint labs, then we will allocate them depending on your preferences, but this will be discussed later in the afternoon. So my presentation is structured into 4 points. So an update on the team, an update on the projects, an update on publications, and also I wanted to give you some messages which I really wanted to enforce. So the first one is team. So In this research increment, we have some newcomers. The newcomers are Lorenzo Moretti, coming in this increment, working in the Isaac team. So Lorenzo joined recently the Isaac team in this research increment. Then we have also Connor. Connor is a visiting student from Virginia Tech under the supervision of Alexander Leonessa. So probably some of you may know Alexander. Actually, he visited also our lab back in time 1 or 2 years ago. And Virginia Tech, right? Yes, Virginia Tech. And I think that there is still an issue, so if you want to look around. So Connor, but he's going to leave soon in August. Then his visiting ends. But anyways, he's working in the X team concerning the interface for the teleoperation control of ICAP 3 towards the finals. Then there is Guglielmo Cervettini. Guglielmo is, I think, here. I saw him around. Yes. So Guglielmo joined the X team, working on. You might know that we are installing new cameras on ICAP 3, for 4K cameras with higher FPS and wider field of view, and then some problems may arise on how to project uh, these new cameras and views onto spheres. So this is basically the project that we were thinking that Guillermo can carry on, and which actually is really important for the finals. Then we have also Ebru. Ebru is also a visiting student working in Iron Cub, so she's going also to leave soon by the end of August. Then we have Dario Sortino, Dario, that I saw him here. Yes, Dario is here. Dario joined the iFeel team to further develop the core electronics and hardware of iFeel. And then we have also Francesca, who joined in this research increment for content production and media. So I wanted to say, do not hesitate to involve Francesca in any, especially for the Scrum Masters, so in any activity, but also for the entire team, in any activity that needs somehow better qualities, better content concerning media, videos, pictures. So we have to somehow increase a little bit the level of how we were doing these things, which was a little bit somehow. Okay, so then we have still 2 open calls, and I just wanted to say that if you know anyone which is good, do not hesitate to advertise them. So the first one is software engineering for the Iron Cup. So we're looking for positions concerning the software engineering development for the Iron Cup team. And then we are also looking for a full stack robotic software engineer concerning the lab. These two open codes are somehow pretty wide, but the Iron Cub one, but this one is pretty wide, so it may touch several teams, and they are used. It is used as a collector also for somehow CVs. Concerning an update on projects, so the last time we talked about Total Spine. Total Spine is a project that we submitted with Fondazione Dognocchi, Campus Biomedico. It's a 3-year project for applying iFeel to low back pain patients. Actually, we passed the first evaluation, but we still don't know if we made it to the end. So we're still waiting for this evaluation to come out. So then the last time we also talked about a current joint lab, which is being discussed between us and Bosch. This also concerns intelligent system ecosystems for human beings. So you may know that actually we use the Bosch IMU, and I mean, by chance we have been contacted by the team that developed the BNO. So it's going to be a great opportunity, I have to say, if we can make it. And what is the status of this? The status is that now the legals are discussing the terms. Okay, so now they're ping-ponging this contract, and we hope to converge, let's say, before September. Okay, so this basically it's an update on the projects. I just realized that I didn't mention the PNRR, so but probably it is something we can discuss better in the next increment. But I just wanted to mention that the PNRR, which some of you may have heard uh, from the news, and also at the European level, you might know that post-pandemic there has been an effort from the EU countries to somehow give funding for somehow getting out from the wave of the pandemic crisis. So the PNRR is a program, a European program, which gives money to countries, and some of this budget will also arrive to the research line itself. So once we will have clearer ideas and directions, we will talk about that. But anyways, things are starting out, and they have to start out pretty quickly. So most likely we have to hire new people or new PhD course. I'm going to talk about it in a second. Will be open in this year. So concerning the that's why also the new desks. So just to tell you. So concerning an update on publications, I hope that they did not miss anything yesterday night. But anyways, so the Stefan's publication on planning a complementarity condition of transaction robotics was accepted. It's been a long journey, I have to say, also this one, but somehow TRO is among, if not the highest ranking publication for robotics. Technical robotics, then we might talk about what's the best. But anyways, so I really advise you to take a look at this paper if you're interested about planning and planning with contacts, because when you have to deal with contacts, it's really important to somehow frame the right conditions that have to characterize the arise of contacts. So congratulations, Stefano, and I really advertise this publication. Then we have also another publication. So the Prashant was accepted to IROS this year. So we have to understand a little bit how who's going to present. So Prashant is connected. But anyways, this is also a really nice publication concerning the comparison of floating-based estimators. You know that somehow we're still lagging a little bit behind on the perception level, and this is the truth, especially for exeroceptive perception. So for proprioceptive perception, this is a really good starting point that I advise you to read. So also congratulations, Prashant. Then there is also this paper accepted to CDC. So Venus was able to keep working on technical developments. So congratulations, Venus. So this is somehow pretty nice approach, a little bit different for dealing with basically boundaries for joint controls. So torque limits, position limits. So I also advise you to read this paper in the case you want to take a look at how to deal with these constraints in a different manner. And then I forgot last time, but this is also a really nice paper. I mean, you might know Martijn, that was a visiting student back in time. He was working on linearization of Lie groups, and actually his paper got accepted. This is a collaboration with Eindhoven. Sakon is really behind all these geometric mechanics. So somehow he helped clearly a lot for writing the paper. Also Silvio, who supervised Martijn helped a lot, but also this paper was a really long journey to make to accept. And in the case you want to get approximations of systems which do not evolve on vector spaces, but on Lie groups, which are basically constrained vector spaces or vector spaces with constraints. So I really advise you to read this paper. So now, some messages I wanted to tell you. So the first one is that I realized that over the last months it was pretty intense. So the team was increasing a lot, and we have these automatic rules for defining meetings. Okay. As we were growing up, somehow the agenda was really crowded, I would say. So it was really difficult, at least, not only for me, but these patterns somehow had an impact on the entire team. And the point is that while we were, at least I was too busy with all the machinery, I didn't have time to think about how to restructure things. So this is also something that I I advise you to not to do. So if there is a problem, so try to act immediately. Otherwise, it integrates in time, and integral actions may not be really nice if you don't put somehow. Anyways, without taking it into technical. So, and the consequence of that was also that one of the things that actually happened is that when you asked me for somehow quick feedback, sometimes I didn't have time to react. Okay. So, and what I most often to say, okay, guys, come back later, come back later. So I was perceiving that this mechanism was really not healthy. So with Marta, we've been working a little bit over the last week, 10 days, in order to restructure a little bit the meetings. And the idea, the principle here is that we want to have less fixed, more variable meetings. So all the ceremonies that are in place are decreased in frequency. This is in a nutshell. I'll show you the numbers now, but in a nutshell. So all the meetings are reduced in frequency, but and this is somehow supposed to give more time to be more present in the lab, to go around and somehow receive and give feedback. But it is really important at this point that you somehow ask for feedback anytime that you need for. Okay, so clearly it may still happen that I say, no, come back later because now I'm busy, or also the Scrum Masters, or so. But anyways, the idea is that by having less meetings into the agenda, we are more free for quicker quick feedback. So just some numbers. This was more or less the structure of the meetings. So as you see, you have duration in meetings, and then a buffer, because this was also another problem that when a meeting ends, if you don't have a buffer, you get a problem. And then there is somehow a period which characterize the frequency of the meetings, and this was basically the period's time on the right column. So you see it, and this is basically what is going on right now. So some of them have been brought to zero. Some of them have been basically doubled. Some of them times 1.5. So so this was the first action that I was forced to take, and I want to try. So this is basically the new organization for the periods in meetings, and then the other action was that I also structured the meetings in two main categories. The first one on research, and the second on technology transfer. So research are basically the three research axes. The technology transfer are sponsored research activities and joint labs and spin-offs. So for the vertical meetings on the technology transfer activities, I'll be put as tentative, which means that Marta can overrule the presence. So But anyways, the Scrum Masters somehow will be there in order to follow the meetings if things need to be corrected. Okay, so this is expected to somehow decrease a little bit the time in my job. This is a little bit personal, but I just wanted to share with you the struggle, because when you do systematic actions, they have systematic consequences. So, and somehow this is going to, is expected to reduce the number of meetings from 207 to 149 per increment, and also the number of hours allocated in the agenda from 220 to 177. So I also wanted to share these numbers because a message that I wanted to pass is that you have to keep an eye on your time. Okay, this is really an advice that I want to give you. Okay, so take a look at how you spend your time, because we think to be somehow creative, and we are, but getting disciplined on how you handle the time is one of the fundamental things in order to have to get, if you want to have things get done. Okay, so the second message that I wanted to give you is that over the last couple of increments, what we somehow perceived is that sometimes people did not know what the other was doing. So this also was something that we perceived. I have to say that probably this is somehow normal, because we are growing in number. Okay, so it's difficult to know exactly everything about what the other was doing. But sometimes we have the really close activities. I just could make examples about FT sensors. Somehow we thought, along with the Scrum Master, a way how to increase the horizontal informations. Clearly, one thing that I wanted to tell is that the GitHub organization is there. So if you see an element coming out, you can watch it. So, and this has to come from you. Okay, so with that said, what we did is that we created vertical teams. So these vertical teams are supposed to somehow have increase the information exchange on vertical topics that we are working on, like control, force of sensors, identification, estimation, and etc. So in the case you think that there is a topic that you need help for, or you think that it is important that other people working on similar topic have to know, just CC them onto the issues. Okay, and this is pretty easy. GitHub allows you to do so. So please do it. And then, in order to make sure that people were belonging to teams, what we did is that we opened an issue. All of you now belong to some of these teams, and then when new members enter, we have also a checkbox on in order to ensure that teams are somehow you take part of the team. Okay, so the other message I wanted to give you is that there are a couple of things that, in my opinion, we have to improve. So the things are are two. So the first one is that I know that you may perceive this a little bit invasive, okay, but and you may trust me or not, but this is actually for you, okay. So the first thing is that try to comment on one issue per day, okay. Few lines are okay. Whatever you do, okay. I did nothing. You did something, okay. So and I mean this is a fundamental somehow activity that someone calls journaling. Someone, anyways. So this is the first advice that I want to give you. Try to comment on one issue per day, okay. Few lines are okay. The second one is that relevant results in issues, please add the commit. Okay, this is really important for software reproducibility. We have been through these problems, okay? Then once we have to release the code, release the paper, you are going to pay a great overhead if you don't do that, okay? So when you feel that there is a relevant result, really, I also sometimes feel uncomfortable to somehow do this public scolding. Okay, so just drop the commit. Okay, and this is really going to help you guys. Okay, you may trust me, you may not trust me, but there are times where, and this happens to everybody, that at a certain time you say, okay, oh Jesus, already 1 year went by. What did I do? Okay, oh, what did I do this year? Oh, I'm already at the end of the PhD. I'm already, I don't know, at the second year of the team of the lab. I am already at the end of the scholarship. So what did I do? So these activities really help you to answer that question, which is really frustrating and depressing when it comes. Okay, well, if you want to, when you pass through the depressing moments, you say, ta, 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 this is what I did, and you get all the history. So, oh, okay, so I did something. Okay, so this is actually is for you. So the second message that I wanted to give you, it is somehow rhetorical messages, but have to be enforced. So try to collaborate as much as possible, really. Try to be open on problems. Try now, we have these new vertical teams. Being open inside the lab is the first step towards somehow cross-validation of your result over the scientific community. Okay, so if we struggle to talk to our neighbors on the desks, for sure we're going to struggle with talking to people in science. Okay, to people asking questions, tough questions. Okay, people do not give you anything for free. So you have to be ready in order to defend your research, in order to defend what you're doing. Okay, so and these discussions happen locally first, then globally. And then clearly, if there are problems, do not hesitate to talk about this. The last messages I wanted to give you, we mentioned that we will have about 6 PhD open positions, okay, this opening soon. So in the case you're interested about a PhD, I still have to frame down, it's going to happen next week, topics and short abstract. So do not hesitate to talk to me, and we will see how things have to be managed. Okay, so I wanted to so this was a little bit different from the other research increment, but I believe that it was important to somehow pass some messages. Okay, so yeah, if you have any questions, I think we can take it. Yeah, really small, short questions, and then we can move on. Any question? No. Okay, great. Now we can get started. Who is Stefano?
Okay. Good morning, everyone. At least according, or a good day according to your time zone. I will present you more or less the activities done by the Telexistent team, or more generally the X team, that involves the activities toward the ANA Avatar Prize competition. Anyway, the people involved are many. Some of us actually now we are getting more and more focused, but some of us also participate to more than one iteration meeting. So it's a large team that involves also deep collaborations with people that actually usually whose main activities are within another group. But okay, within the team, we're trying to merge, we're trying to blend together the activities of several directions of the lab, basically. During this increment, we are we're about to have some changes. So we had Sander visiting, he already left. We had Kurosh that left during the increment, and also Prash, unfortunately, is about to leave. Um, we have also another addition that is Guglielmo, as Danny presented before, that will help us in the development of the VR application involving newcomers. We do focus a lot on ICA 3, and since uh, since when we started about more than 1 year ago at this point, uh, we needed a lot of help on the robot in order to push forward development, push forward the developments on a machine that was basically new. So we had a huge help from Team Fix, from iCapTech, and also other members within iCapTech that help us in making what the robot is right now, basically. So that help us in every issue that occurred during this past year. So the mission, I've been repeating this over and over, but I think it's worth to repeat it. So we focus on the integration. So we integrate algorithms and technologies on a walking humanoid robot toward an advanced avatar system for participating to the Avatar Express competition. Now, the Express competition has been this several years long international competition that required us to develop an avatar system, so something that is specific to teleoperation. So the autonomy is left more on a side. And in order to participate in this competition, we did have to integrate different technologies. I can think, for example, about the robot, about all the field technologies, but also algorithms, something that we have been developing during the research activities, and we had to push forward and to ground into this major project related to the development of the avatar system. So the last research increment was on 21st of April, and I was presenting the output of I was presenting what we did at the semifinals. And actually, the very same day, that day, we received the communication that we made it to the final. So if you can actually look at the square red down there, I just took a screenshot of the email that, again, we received on the 21st of April, where they were communicating us that we made to the finals. So we are one of the 20 finalist team that will compete for the Express competition in November in Los Angeles. So I think this is a major achievement for us. I'm very proud for the team. I'm very happy about the result. And this will help us, will allow us to showcase our technologies and our approach to the avatar system in a very international scenario. So we will be headed to Los Angeles, and we'll be in this huge convention center with people coming in. So it will be open access, so we will have some public. And this right now is really a challenge, not just to participate to the finals, but also to get there. So shipping the robot will take a month, and we don't know yet what we will have to do during the finals. So we will have just a couple of months, and this will pose a major challenge for us for the following increment. Now, looking back, what happened during this increment? Well, we've been involved in several activities, and out of that, we got a lot of nice pictures. So there was also like a nice outcome. So the first one was a visit from a professional photographer. And he wanted to have the robot on the parking lot here at the top of Chris to shoot some images that then have been bounced on several news and several articles related to robotics. So this was actually in May, so like a few weeks after the research increment. Then another major effort for the team during this period has been a demo in Paris. So we've been invited in the Italian embassy in Paris during the Republic Day, the 2nd of June. And we had the chance, to meet some former minister. And so I was basically teleoperating the robot. So I could say that I did a toast with a former minister, even not directly. But it was also kind of fun. It was fun So there were thousands of people around, all well dressed, let's say. So we had the occasion to go around with the robot to show, do some small show in the middle of the people. Talking about shows, so we had this other huge event in Rimini, where there were a couple of thousand people in this big auditorium. We had the robot on stage, and we had yet other cool pictures of the robot. So here the robot is fully untethered on the stage, being teleoperated by Gianluca from Genova. And that beast over there is Enrico's one who was wearing the actual suit on the stage. So yeah, I wanted to pick like the best looking pictures. There were many. I will invite you to look at the issues in Lab Event Demos. There are really some nice pictures. This was also yet another important event, yet another task for us, because we had to coordinate again two different teams in a very particular setting. So we were backstage with no lighting. There were 2,000 people in the room, so Wi-Fi was an issue. And actually, right before starting the event, I wasn't able to connect to the Wi-Fi of the robot, so we had to, like 10 minutes before, trying to understand how to talk to Genova, because I was disconnected. The day before, we almost burned the battery, so we weren't quite sure about the status of the robot. And so, yeah, despite that, we were able to pull this off and being able to have both the actual system and the robot on stage doing a collaborative demo. That was kind of cool. It was really nice and also really funny. Gianluca did a very nice job also in entertaining the people there. So it was really cool to see. Now I regret not to have put that picture, but we have we could have seen the robot moving and Gianluca very big on the big screen behind from Genova, and we can see the robot imitating the motion. So it was very cool to see. Very nice experience, and also time consuming, of course. Then later, a couple of weeks ago, we had another visit from a German television. In this case, there was a German presenter teleoperating the robot and playing with Danny with some gestures. So yet again, once more, we had the chance to try again the system with someone that was completely untrained. So with this guy arrived and half an hour was inside the robot. Well, probably a bit more than half an hour. But anyway, this was yet another task for us for the system. So although all these events so far have been time consuming, I want to stress the fact that this is really when we were able to push development consistently on the robot, because we had a deadline, we had to make things work. So although these events are often, I mean, from before the event is often time consuming, then once we do that, it's very nice to look back at the picture, say, okay, I was there, I was part of it, and also the amount of new things they were able to push, even they might be small, but they're always small steps toward the end goal of getting to the final. Okay, moving on to the actual milestones. So what we presented during during the previous research increment. So well, the first point was to prepare the final scenario if we make it, and yeah, we made it, but we didn't prepare them so far, because right now we don't know yet about the scenario. So they will XPRIZE will release them on the 8th of August. So we don't know anything yet. So but we do know that there's not going to be any rough or non-planar terrain, but nonetheless, we started the activity of modifying part of the working architecture using DLF, and Giulio and Paolo are actively working in order to merge Adherent and Central PC together. We wanted also to start testing online-based estimation on the robot. This activity unfortunately hasn't started, but the focus has been much more on the human side. So although back in time we decided, okay, we want to try on the robot, then especially for the Rimini demo, we did work a lot on the human-based estimation. So the activity has been basically derailed toward a different platform somehow. Then we started it. We've been working on the analysis of the FT. We were we've been working on the on using again the compliant mode on the arms. We are investigating more on the performances of the FTs on the arms. While we weren't able to extend a lot the FTs modeling yet, so this is something that started. We weren't able to get major results out of it yet. We also wanted to deal with more performant cameras. This is something that is arriving. This has been an activity that is more on the architect side. So they are developing the new mechanics, electronics in order to sport some some more powerful cameras. We've been focusing more on the lenses. Also, we've been testing some new lens on the robot, and we Guglielmo, we also started some new activity in order to deal with these high resolution cameras. I didn't have any basic working feedback. Initially, the plan was to use the virtualizer, but one additional rule from XPRIZE is that we have to set up the entire operator system in 75 minutes. This setup includes bringing the PC into the room. The virtualizer weighs like 120 kilograms, and took us last week. It took us 4 hours to mount it and mount it back. So clearly, we had to change the plans. Nuno is actually working on is working actively on the logging visualization. So he managed to bring a lot of new improvements. So the camera visualization is better. It's easier to add logging ports, and he's working right now in adding a visualization of the robot. I want to stress is also this involved putting his hands into a framework that wasn't developed by us, was developed by NASA. And he had to debug and apply new features on something that wasn't actually, it was something that we were supposed to use and not just to modify. So he had to spend a lot of time on that as well. Then we are developing the work gloves, and it is arriving. Just yesterday, we had some new courier results where we were able to get the motion, the opening closure of the fingers from the glove. When instead there wasn't enough bandwidth to use the real sense in VR view, and yet it's not clear whether this will help or not. So it's something that we thought about but never started. Also, I didn't put any formal test on the delays on architecture. It's something that I wanted to do in these days, but then it got delayed again. One instead, we didn't have any more improvement on the sense glove, but okay. We knew later than the crush was about to leave. And also we didn't work on the stopper and starting of the retargeting. This is something that we thought about doing, but we didn't start. For what concerns the research milestones, so it's something that is less related to the competition. Roberto is currently working on a nonlinear MPC trajectory planner, and he's planning to attach the humanoid robot to that, and instead we decided not to consider or at least to pause the activity related to the uneven terrain with the D-rent, because right now is no more of a strong priority. One instead, we did focus more on the online pipeline and the use of a D-rent with Ecca3. It's something that is really about to arrive. We also started the activity related to the use of MPC with adherent. It is something that will take some more time. We will have to move from a very dedicated infrastructure. The current walking infrastructure is very keep us walking, right? So switching completely to a new architecture will take time and intermediate steps. So we're taking a step in that direction. Instead, for what concerns dynamical planner, I was able to make results more reproducible in the sense that now the results run on GitHub Actions, and just yesterday on Docker. But being able to reproduce it, I have the same results on different machines. But unfortunately, this is something that yet is not clear. So it's on that side, we decided to take another step, another direction for reproducibility. And instead of concerned interfacing with the event, I was completely swamped by the reproducibility, and I wasn't able to work on the interface with the event. And finally, Ines started the activities for the camera filter and photo estimation. This activity started. So we had a bunch of PhD theses. Prashant successfully defended his thesis. Julio, in a couple of weeks, probably, hopefully, he will be defending his thesis, while Diego is arriving. Then for focus to the manuscripts, okay, we landed the kinematic tensor free state and floating base estimation by Prashant. It was one of the papers that Danny presented before. We didn't manage to have a paper for concerning the use of the globe by from Kuresh. And this paper on the teleportation pipeline is something that we discussed. It's something that we'll have to work probably before August, but is something that still have to come. It's still on the archive, but it has not been submitted yet. Then Nuno, Venus, and Giuseppe are working on the paper on the implementation of Matter Simulator. I think this is also about to arrive. And the Terra paper has been accepted, and we just received the proof of read from the final version, so it's about to be published finally. Statistics. I'm getting a little bit long. So not much from this graph, apart from the fact that the backlog is slightly increasing, probably due to the fact that we are continuously opening new tasks. So trying to find, say, during this increment, we kind of spanned a little more the research directions, and probably during the next one, we'll converge much more toward the finals. The closed issues are probably include all the many repos that are in the board, so they're like 35, but they are less than past research increment. But in that case, we had the finals that were a huge huge pool maybe, for closing issues. Unfortunately, it's definitely not visible, but you can, the standard deviation is basically following the green line, and you can clearly see when we had demos. So when we had demos around here, I don't know if you know, you will come. Don't even. Here, so at the beginning of May, then in May we had some break, and then here in June we had tons of demos. So we, again, when I saw this yesterday, I said, okay. So again, this is what happens during demo. So we do push a lot. It's super stressful, but indeed is when we get things closed at the end. The release report is always between 40 and 50. It's less than last research increment, again, because we were closing a lot of issues related to the semifinals. Instead, here we are mostly opening and pursuing new directions. We'll just glide through the burnout. They look mostly similar. Apart, okay, when we have for example, the sprint from May 24 to June 7, we had the various demo in the middle, and we have many more issues, many more history points in those parts. Going really fast, and I think that I can close here. So thank you very much for the attention, and thank you very much for the team again for the great results.
Any question for Stefano? No. Okay, so let's thank Stefano again. So please take a look at the visualizers, activities, because I think that the X team did a great job, both for the online and also for the offline. Okay, I think that now we can move next with Prashant from the cloud. Is it crowded in the cloud?
Right now, kind of no. I expect everyone is in.
Prash, we don't hear you very well. I don't know if you can, I don't know, increase the volume, the mic volume, or get closer to the microphone.
Yes, now can you hear me?
A little bit better, but not that good.
Okay, that should be a problem because I think the sound is at maximum.
Okay, probably you might try to speak a little bit louder.
Yeah, sure. I'll try to be.
I don't know what time it is there, by the way.
No, it's a time to speak louder, so no problem.
Okay, so we're fine. Okay, Prash, the stage is yours.
Okay, I hope you can all see the screen, right?
Yeah, perfect.
Okay, I begin. So, hello everyone. In this vertical, I'll be presenting to you a unified approach for whole body kinematics estimation of robots and humans. For both robots and humans, these are systems that are floating based systems with high degrees of freedom. This means that they are not fixed to their environment. And this in turn means that in order to describe the kinematic configuration Q of the system, in addition to the joint positions S that describe the shape of the robot or the human, we need an additional term H, which represents an additional 6 degrees of freedom, describing the position and orientation of a chosen base link with respect to a fixed frame A. And similarly, for the system velocity, in addition to the joint velocities, we need velocity of the base link with respect to with respect to the inertial frame A. That is again a 60 velocity. And the issue here is usually the base state is not measurable, and further, if we consider humans, and if the human is not equipped with an exoskeleton, we do not have information about the joint states for the human. And in case of the robots, if the encoders are broken or they provide really noisy measurements, in that case, we do not also have the joint states for the robot. So in this case, the question becomes how to estimate the joint state and the base state for both the humans and robots in a unified manner. One possible solution is to model the robots and humans as multi-rigid body systems with rotational joints and make use of distributed inertial and force torque sensing that are available on the robot or one available on the human through variable technologies for kinematics estimation. In particular, for the human, on the left, we see they can vary they can use a fully sensorized suit equipped with the distributed inertial sensors rigidly attached to different links on the body, which can enable a real-time motion capture. And simultaneously, as for four-stock sensorized shoes worn by the human can measure contact wrenches or ground reaction forces exchanged with the environment. Similarly, on the right, you have the robot iCurve, which is equipped with distributed force-torque sensing and also inertial sensing, in particular three-axis linear accelerometers and gyroscopes across the body. And specifically, the force-torque sensing, along with an IMU, enables whole body dynamics estimation on the robot that gives us information of the contact wrenches, which can be useful for the kinematics estimation. So the proposed approach here is starting from the variable suit, sensorized suit. We have target rotations and angular velocities computed from the IMU measurements, which are distributed across the different parts of the body. This passes through a dynamical inverse kinematics block to obtain a joint state information, and simultaneously contact wrenches measured by the sensorized shoes are passed through a center of pressure based contact detection block to infer the contact status of chosen candidate points on the foot. And the joint state and the contact state are again in turn passed as inputs to a contact aware external Kalman filter to retrieve the base state. So it must be noted here that with the measurement set of just the absolute IMU orientations and the angular velocities given by the IMU, only the joint state is almost fully recoverable. The base state is not fully recoverable. This is why we complement the dynamical inverse kinematics with a extended Kalman filter approach for the base state estimation. So a deeper look into the dynamical inverse kinematics. Here we see that a limb of the human is equipped with IMUs rigidly attached to the different links, and these gives us the target measurements. And the aim is to retrieve the joint state, which is here we can see the knee or the hip joints, in particular joint velocities and joint positions. And the idea here is to consider a dynamical system such that control input drives the forward kinematics of the system towards the target measurements given by the IMUs. So in particular, target rotations, link rotations computed from the IMU are collected within the tuple X, which is related to a forward kinematics map H as a function of the system position or the joint state Q. The velocities, angular velocities measured by the gyroscopes on the IMU are collected within a vector v, and this is related to the system velocity nu through the Jacobian, which is again a function of the system position q. So this forms a dynamical system, and we define an error between the expected kinematics and target measurement kinematics, such that it follows a linear differential equation, as you see here, in such a way that for a positive k, the error decays to zero over multiple time steps. So, as looking at the block diagram of dynamical inverse kinematics, starting from the left, we have the inputs, link velocities, and link rotations computed from the IMU measurements. And starting from the bottom left, we first compute a residual vector, which is basically an error or a distance between the expected rotations computed from the forward kinematics with the current state and rotations of the rotations computed from the IMU measurements. And this residual vector, along with the link velocities, again measured from the IMUs, are used to form a corrected target velocity vector, which acts as a sort of control input. This is then passed to an inverse differential kinematics block, which can internally run a particular kind of solver, maybe a weighted pseudo inverse or quadratic programming, enforcing different types of constraints like joint limits and joint position limits and velocity limits. And as an output of this block, we get the system velocity, which is then integrated to obtain the system configuration. And in particular, with this measurement set, as I mentioned earlier, we're mostly interested in retrieving the joint state. And this is in turn passed as inputs to the EKF. For the contact detection block, the idea is to choose a simplified geometry for the foot and choose a set of points, candidate points that for which we want to infer the contacts. And we decompose a contact wrench acting on the foot to normal forces acting on these points. And since these normal forces, and then it becomes easy to apply a threshold on these forces to infer the contact states of these chosen candidate points. So for the simplified geometry, we approximate the foot to have a rectangular sole, and the candidate points are chosen as vertices of the rectangular sole, and the decomposition happens decomposition of the contact wrench to the contact normal forces happens according to the position of the local center of pressure on the foot, which is computed using the contact wrench measurements and enforcing the geometric constraints of the foot. For the contact aware EKF, now we have both the contact states and the joint states. So we move on to the contact aware EKF. The idea is to augment the base state integrator from the dynamical inverse kinematics with contact aided kinematic corrections through an external Kalman filters prediction correction framework. And in particular, we consider the state of base force and velocity, and we augment the state with the position of the contact points on the foot and also the foot rotation. This is useful to improve the state estimation, and also is useful information in general for the controllers. And since the EKF follows a prediction and update step, for the prediction step, we assume the following system dynamics. In particular, for the base state evolution, we assume a null acceleration model. And for the foot state evolution, we assume a null velocity model. These are pretty conservative models, and especially for the foot post evolution, when the foot is in swing phase, this model becomes completely invalid, in which case we dynamically scale the covariances to very high value to not trust this model during the swing phase. And for the EKF update, we use the following observation models. The first two models are from relative forward kinematics. We have the position of the contact points and the orientation of the foot with relative to the base. And then we have the angular velocity of the base directly measurable from the IMU. So we pass it again as measurement. And the rest of the observation models are what makes the EKF contact aware. In particular, when we know each of the candidate points are in contact with the environment, we enforce the holonomic constraints for these contact points to compute the base velocity, and we use that as a measurement in our EKF. And further, when we know each of the point is in contact with the environment, we enforce a height measurement from a known elevation map to to reset the height of the base state according to the height of the contact points. And when more than 3 points are on the foot are in contact with the environment, we enforce the contact plane orientation to reflect directly onto the foot orientation. So looking at some simulated experiments on the robot, here we see an experiment of robot backward walking, where the target measurements are simulated using Vicon ground truth trajectory of the base state and the encoders for the joint state. And the dynamical inverse kinematics is solved using weighted pseudo inverse for the differential kinematics with uniform weights. Here in the bottom, you see reconstruction of the joint state, the velocity and position for the hip pitch joints of the robot. And you can notice that we have a reasonable reconstruction that matches the encoder measurements. Here, the use of weighted pseudo inverse with uniform weights results in high norm estimates of the joint velocities and also a bit of noisy velocities. This can be tuned to achieve better estimates. And similarly, for the base velocity reconstruction as the output of the EKF, we have fairly reasonable reconstruction in comparison with the Vicon measurements. And again, it must be noted that the weighted pseudo inverse causes the estimates to suffer from high norm values. Here we see an experiment on the human where the human subject is performing in-place walking. On the left, you can see the human wearing an Exen suit, and in the right instead, he's wearing an iFeel suit, which is in-house developed by our lab. And in particular, it must be noted that on the left, we use weighted pseudo inverse in the dynamical inverse kinematics to solve for the joint states, and in right, we use a quadratic programming enforcing joint limits. And it can be noted that using the quadratic programming with joint limits results in much more physically feasible motions in comparison with the weighted pseudo inverse, where we can see some sort of self collision happening in the reconstructed motion. And it froze. Okay, here we see a walking experiment conducted by the human, and you can see that the proposed estimator fairly reconstructs the expected motion. However, it has its problems, especially at the contact events where there is a high norm orientation introduced. Inside the estimates here in comparison, we have a baseline estimator, which is basically the dynamical inverse kinematics without the EKF, but enforcing the legged odometry internally within the dynamical inverse kinematics itself. So we have fairly comparable results on both the algorithms. And as a conclusion, there is, of course, a huge room for improvement for this estimator. Firstly, the prediction models used in the EKF are too conservative for dynamic motions, especially for humans. And this we might investigate into locked inertia dynamics or strap down inertial dynamics or even learn prediction models for the system dynamics of the EKF. And it must be noted that the target orientations rely on absolute orientation, IMU orientations. And these IMU orientations are usually use magnetometer measurements internally and which are not very reliable for long-term operations and can cause drifts. And the precision of contact inference for can be improved by combining also vertex velocities and positions by combining both dynamics and kinematics information for contact state inference, which can improve the precision of the contact state detection. And finally, we can also improve the quality of motion reconstruction to achieve more realistic motions by including self-collision avoidance constraints in the dynamical inverse kinematics. So overall, I presented a unified framework for whole body kinematics estimation for robots and humans, and now I'm open for questions.
Okay, let's thank Prashant. Thank you very much, Prashant, for this presentation. Actually, this is your last research increment, if I'm not wrong. So, any question for Prashant? Yes, Gianluca.
Hi Prash, can you hear me?
Yes, John, I can hear you. Hello.
Okay, my question is, you in the final slide you mentioned about the possible open point,
Yes.
and so my question is, which do you think could be a solution to the second one, so relying on magnetometer dependent solution, absolute orientation might cause drift in long-term operation.
Yeah, okay. Regarding this, we have, I mean, we have had many discussions in the past, and right now there are three possible alternatives that comes to my mind. One is the first one is reformulating the inverse kinematics completely to use only accelerometer and gyroscope measurements. That requires some rewriting of the mathematical part. And the second one again is depends on learned measurement models, where you can use, for example, Vicon markers uh, the on the I field nodes, and to understand if somehow learning some measurement models known sorry, learning some measurement models based on these Vicon inputs can replace the dependence on magnetometer measurements completely. And the third one could be that I recently came across a possibility that the temperature variations in the IMUs can also affect the magnetometer measurements. So some research in this direction can also possibly improve the estimates or reduce the drifts in the estimates.
Thank you very much, Brash.
Yeah,
Thank you.
concerning the learning, probably there is going to be a PhD call exactly on that. So combining supervised learning with extended common filtering for better estimations of the human postures and floating base. Okay,
Yeah,
any other questions? Yes, Trash, sorry.
no, I was saying that would be really interesting.
Yeah. Okay, so any other question? No. Okay, so let's thank Trash again.
Thank you.
And I think we can move to the next speaker. I don't remember who he is. Lorenzo. Okay. He or she. Ti ha attaccato?
Sì, non me l'ha visto.
Ok.
Ok. Okay, so good morning, everyone. Yes. Okay, so I will be presenting the updates on the activity of the ErgoCab team in the last research increment. So the content in the presentation, I will just give a short review of the team, and also give an overview of the project for those that are new. I know many of you already know about the project and the main objectives. Then I will present the milestone that we addressed during this research increment and the statistics. Okay, so starting from the team, so there are not big changes in the main team, but we have Dario, which recently joined the IFIL team, which is always a support for the ErgoCap team. So as you see, we have the team is composed of the ErgoCap side, but also a member of the IFIL team are also part of the ErgoCap project. So concerning the project itself, so the ErgoCap project is a project that we are doing in collaboration with HSP Research Line and CapTech, and it is sponsored by INAIL. So we started the project on June last year, and we are now going to address let's say the first demo, the first review on December 2022. So this activity was postponed because at the beginning was meant to be after 1 year of the project, and the total duration of the project is 3 years. So the main objective is the application of ambient intelligence and collaborative robotics for risk prevention in work environments. So we see there are many different points that we try to address. So concerning the ambient intelligence, the objective is to develop some sensor technologies and algorithm for estimating yes. I don't know then. Yes, we can do that. But, no, exactly. If another one is connecting, it's no, we're not doing the sound. No, just another member. You can connect two things. I'm not sure I want to open my Teams in the big screen, but the link. No? Ah, sì, okay, okay.
Guys, can you see Lorenzo's monitor now?
Now, yes.
But do you see the presenter mode?
Yes, it's the presenter.
I'll share it again. Let's go this way. Okay, can you see the screen in presentation mode now?
Yes, now it's okay.
Yes,
Okay,
yes.
great. Okay, so sorry about that, but okay. So I will go on from here. So we were just talking about the objective of the project. So the first one concerns ambient intelligence. The second one concerns the collaborative robotics. So we need to develop both robots and algorithms for human-robot collaboration, basically. The third objective concerns the risk prevention. So this is why we want to use both the ambient intelligence and the collaborative robotics. So the final objective is to achieve risk prevention in work environments, which is the last point then. So concerning the, let's say, the map of the project, so inside the project, we started by defining some some scenarios, some reference scenario, which involves both in an industrial settings and healthcare settings. And we are going through the process to reach final experimental validation of our activities. So the main path follows these four different topics. So developing of perception algorithm, of biomechanical risk evaluation algorithms. Then we need to achieve a navigation and planning for the robot in the reference environments and the robot control. Then we have some parallel activities, which concerns on one side the modeling and the simulation of the environment of the robots and the human, and on the other side the developing of some hardware concerning both the wearable technologies and the development of actual robots. Finally, there is an additional task which concerns the analysis of the usability, acceptability, and social impact of all the technologies that we develop, and also for the behavior of the robot itself. So going through the milestone we defined in the last research increment. So we can start from the part concerning the perception algorithm. So the algorithms to perceive the human and its kinematic and dynamic state. So we work on this release of the HD library, so the library for the dynamics estimation with many different new features, which are not that new, but were never finalized and released. So this is basically complete. Just didn't close it because there are still some a few PR pendings. But in these concerns, we basically make it back on track the stack of task estimation of external payload for the human and for the human joint torque estimation. So this was in place back in time, but we struggle a lot to have it working again and to have it in basically a stable branch with all the new additions and also with the possibility of using the IFL suite. So we finally reached these results. Then, so this somehow postponed the second activity since we have still some not fully clear idea on how to proceed on this, but since we finished the first part, we have all the pieces in place, so we can basically collect them together. Then, concerning biomechanical risk evaluation, we work on developing a risk prediction during lifting task, so algorithm for risk prediction, and also another step was to implement some risk evaluation methods found in literature in order to achieve an online risk evaluation to exploit our technologies. So on this part, we work with some old data set we collected. So those are some preliminary results. We basically applied the framework used back in time by Kurosh for prediction during working task, and we try to apply these to, as I was saying, to lifting activities. And yeah, then the other point was to have it online, also the assessment of the risk accordingly, in this case, to the NIOSH, which is basically a standard for assessing the risk during lifting tasks. Then concerning modeling and simulation, we iterate a bit again on the integration of the EMG sensor with the dynamics estimation. So we collected some data set and we are now back focused on these activities. While for the time being, we skipped these objectives, so we didn't put, apart from some preliminary investigation, we didn't work on the generation of the new human models. Then, so concerning the control, so I'm still working on this part since we had some experimental results, but clearly we need to do some additional validation on the results to have somehow a stable. Some results that we can present in some submissions. So those are just some more recent video with respect to what we showed the last time. Not sure if it's running. Yes. Okay. So in this case, again, we have the collaborative lifting with ICAP3 trying to use also the human data inside the control of the robot. Then we work on the implementation of working controller with modified centroidal momentum. So this will be the vertical presentation, so I won't show an image. Then we work, Evelyn has been working on this activity on motion generation, also thanks to the help of Paolo from the X team. So she worked on a literature review, and then she worked on adding a new feature to the adherent framework in order to allow the robot to crouch, so work in a somehow different with a different posture. And we acquired some data for this feature, train the network, and basically implement all the feature to have this new action inside the adherent. And then the last activity was somehow postponed, but will be the next step. So learning how much we struggle in order to add like a new feature to the full framework. The objective then will be to have somehow a modular learning of new trajectories. So those are just the preliminary result. On the left, you see the retargeted data. So those are simply the data of the human retargeting to the robot. While on the right, you see the adherent framework working with the robot walking both standing and then crouching, I guess. Should I go for overlap? Yeah. Okay. It's towards the end. Okay, yes. So in this case, the robot is also able to work with this crouching posture. Then moving on, so we work on the exoskeleton, on the implementation of somehow simulation of the PEX, which is the exoskeleton we're using in Gazebo, and also first control on the PEX working in simulation, which concerns also the identification of the model of the PEX. So here we have just some two short vid on the left. It's the human in Gazebo with the external force due to the presence of the simulated PEX. On the right, just some experiments with the exoskeleton to basically identify the model of it. Then concerning the acceptability, we collected some material from the existing robot, and we somehow draft a first questionnaire we want to propose, and we are working on with Ipsos to basically assess how the robot is perceived accordingly to different designs and different shapes. So this is something that is still in progress. We still need to finalize it, and we will need to have some material to show, but we have the draft of the questionnaire itself with the help of Inel. Then concerning the robot design, so we are monitoring the activity of the external design studio, which is working on the new cover of the robot. So this is still in progress, but I think by September we will have some final concept, some final prototypes. Then we work on the genetic algorithm for optimizing the hardware of the robot. So we introduced the motors in the model of the robot. So this is basically the model of the stick, which is called Stickbot, which is an avatar for the future ArgoCab robot. And we also try to define some optimized posture for a collaborative lifting task by changing the shape of the robot. On the left, it's the ACAB 3, which has a small size, and then on the right, the ArgoCab robot. Then we work just as a final part on the validation of all our technologies in the context of ArgoCab. So we did some analysis on the data we. Oops, okay, I missed the video. Later. Okay, we did some analysis on the data we collected back in time in Aeroporti di Roma. So to compare the team lifting and the single lifting with some interesting preliminary results. And we also are working on the submission to the ethical committee for future experiments in Aeroporti di Roma. So overall, with respect to the previous research increment, we somehow increased slightly the number of milestones that we closed. So we are slightly above 50%. So hopefully we are improving, we are improving in evaluating our possibility, our activity during the research increment. Just to conclude, we have the statistics. So here we have the cumulative workflow. So as usual, this seems to remain more or less constant in backlog, in progress, and review number of issues. We have just a final sprint. We see a final increase on the curve. Then concerning the control chart, this is the one from the previous research increment. This is the new one. Again, it seems to be more flat now in this research increment. I have no a particular explanation for that. And the number of closed issue has slightly decreased, and the time for closing them is slightly increased. And then for the release report, again, this is the one from the previous research increment, and this is the new one. I noticed there is like this flat part in the center on the total scope, but then the complete also in the completed points. Probably this is because we just finalized everything towards the end of the research increment, so that's probably the reason. Okay, thank you all.
Any question for Lorenzo? I have to say that the results on the SWOT was really nice to see it working after a long time. Yeah. And before we talked about a little bit reproducibility and why it is important. So Riccardo just went through one of these processes where the overhead had to be paid, not to integrate things correctly before. So if you want somehow some nice user experience of not integrating results in the beginning, you can talk to Riccardo. And what I was thinking, Lorenzo, now we can also run the SOT with the data that we acquired on Rome, right?
Yeah, actually, this is something we were all planning to do yesterday. Then we prefer to test the demo. So we had these two options to test the demo or the data. Then we test the demo. But yes, actually, we are planning to do it.
Okay, really a lot of nice results in ErgoCub. So let's thank Lorenzo again. And we move to the next one, who is Mohamed. Probably the trick is working out of sharing the directory. There is one. You can also use this. Yeah, but okay, for people from the cloud, now we are trying to use again but you have to touch the HTML. Do you see anything? Cloud?
No, we don't see anything.
They don't see anything.
Yeah. It's not even. It's not even here.
Oh, yeah, no. Okay.
No, but the problem is not the USB, that they don't see.
Yeah, but
So probably you use your laptop and you share the screen as Lorenzo did. No, because I fear that we get stuck to this. Yeah, let's try. Okay, so probably you can open Teams and okay. I don't know if the cloud not yet because we have to share the screen. Yes. Cloud, do you see anything?
Yes. We see the screen, but not the slides.
Okay, I think that they're coming. Okay, Mohammed.
can I see the
Can you see the slides?
Yes.
okay.
Presentation mode?
Now, yes.
Okay.
Okay, perfect.
Yeah.
So start. Uh, so today I will be speaking about working with payloads using, well, this is a long title, no? But okay. Payload aware and context stable force parameterized centroidal MBC. The outline of the talk is first we will introduce the centroidal MBC dynamics under the effect of payload. We'll use the framework developed by Julio to allow the robot to work with payload. Then we can try to see if we can improve some things with respect to the speed of the preparation of the controller controller function, and then by removing some constraints. And this we will do using the work developed by Gabriele. Yeah. And then we will see the results and what's next. Okay. Okay. So to start, generally the centroidal momentum dynamics can be described in a control affine form as usual. And in fact, the drift vector field and the control vector field take this nice shape, which allows us also to modify the cost function later on as we see. And to arrive at this form, all you need to do is to select your states in this way. Uh, so you will be tracking the dynamics of the centroidal quantities, of the linear and angular momentum, and of the contact locations. We will also consider the contact location as a dynamic quantity, just to say that when there is contact, then the contact velocity is zero. Okay. More in detail for these various terms inside the control vector field and the drift vector field, by simple calculations, you can arrive at these expressions. They're not very particularly interesting. Only these matrices are interesting, the AF and AB matrices. And AF and AB matrices are the usual matrices that include the skew symmetric terms here. We highlighted these terms in blue because we want to say that the contact matrices corresponding to the payload will be assumed constant, because we will assume that the payload is always at the same contact location with respect to the center of mass at the hands. And this is an assumption that will help us a lot. Okay. So with this, we can formulate the problem, and this is the main general problem, and it's taken from this work. As we said, we will assume that the payload contact is fixed, so the matrices multiplying the payload in the dynamics are fixed. But also we'll assume that during the prediction horizon, the payload is fixed as the current estimate of the contact forces of the payload. Okay. And so we have this general MBC problem in which we have three tasks. The first task corresponds to the momentum and centroidal task. The second task is just a force regularization task. And the third task is a task analyzing the deviation of the contact locations from some nominal contact location. The terms highlighted in red will be important for us. Of course, this problem, this cost function is subject to the dynamics with the payload aware term, and also with the usual contact stable force constraints and some constraints, some constraints on the deviation of the error of the contact locations. Okay. So this is our problem, and we can run this problem and compare that when we include the payload versus when we don't include the payload. On the left is when we don't include the payload, and we see that the tracking behavior for the center of mass is a little bit not nice. On the right, you see that it keeps the center of mass very vertical on its initial condition, on its initial assumed peak height. Even the changes in the state adaptation, as you can see, compared to the one on the left, are better. Okay. This when is running on the actual robot, we need to do a lot of tricks. So we need to overclock the CPU because it's a nonlinear MBC problem. We need to and we need to use a particularly fast solver, etc. So can we modify the problem in such a way as to make it a little bit faster? Hopefully, I don't know. So this was the intuition. And to do this, we thought of removing one of the constraints. or the main constraint on the forces using this contact stable range parameterization. So assume that I have a contact range at some contact location. We know that to keep the contact stable, we need to enforce these constraints. These constraints are particularly that the force normal at the contact location should be bounded by some minimum value, which is positive or non-negative at least, and that the limit on the force parallel to the contact should be bounded by the static friction coefficient. These two indicate that the center of pressure should be within the contact location, within the contact surface. And then the last one should mean that no rotation along the field. Okay, so, and this is typically can be overcome by instead working over a parameter such that, and this can be found in this work in fact, that you take a parameter C and then you replace your contact range with this map, right? And this map has an invertible Jacobian, etc. It's very nice. And so instead of writing this constraint in your control or optimization problem, which that your contact range belongs to this set or some approximation of it using a linear inequality, you can just remove your contact range from the optimization problem and optimize over this C variable. Okay. So the modified problem now has less constraints. Our optimization variable is C, and we add also in this case a new term in the cost function, not only penalizing regularizing the contact forces, but also removing the effect of Bellot, and this is calculated by simple feedback linearization-like techniques. And so we arrive at this simpler problem, okay? And so we tested against the original centroidal MBC. We increase the Bellot a little bit, and we notice that we get nicer results on the right. Not in terms of stable adaptation, but in terms of the center of mass tracking, which is very nice. This also was encouraged by the fact that when we look at the individual iterations of the solver randomly, we notice that at least few milliseconds of improvement happens, not on the actual time, but on the clock time. But the main benefit happens when you actually, at the beginning of running the software, because you need to prepare the Casali function controller, which takes a lot of time. And there we have much bigger improvement in time. Also, we tested this after implementation of the system in C++ on the robot. And on the left, the fairest iteration of the implementation, the robot takes a few steps. You notice that there is this shakiness. It's not only because of tuning, but also because the individual blocks of the MVC and of the whole body controller miss some deadline. Then with some tuning, we notice that also we can get better results, but also that we don't need to overclock the CPU anymore to take few steps. And yeah, I think we are in a nice position now to add the payload and to see some results. So what's next is, yeah, add the payload and collect some data, and to repeat the experiment as much as possible in a Monte Carlo-like scenario to have some nice analysis. And we can investigate if we can make some formal statements, at least about the recursive feasibility of the problem. So given that the original problem, the centroidal MVC, is solvable against a solution, can we always ensure under this parameterization that there exists a solution? And yeah, these are the general.
Any question? No. Okay, so Mohammed, this was a really great work. So I think that this is basically a publication. So you're heading there because this is really nice. So really congratulations. I really like to see how then you were able to attach.
Yeah, the work of Giulio and Gabriele.
Gabri, yeah. Probably it can be also help to other NPC guys working in a similar. Yeah, Stefano.
Thanks, Mohammed, for the presentation. Can you show again the times? You notice, like, where did you notice the improvements?
So there is two aspects. The first aspect is which is I'm not showing here, is the control. So in the software, you need to first produce this Kasabi function, which is the controller that takes the inputs and produces your optimizers. And this takes time to prepare this Kasabi function because it's temporary. And here there is much more improvement. And then on the single iterations, every time you iterate or you simulate, you notice that there is a few milliseconds drop in terms of the MPROC and LWOC.
So I was wondering if you noticed like some, because the evaluation of the constraints in LPT is basically the same, right? So that's why I wasn't understanding why the.
You mean the Jacobian of G? Yeah.
No, the evaluation of the G function, the evaluation of the constraint.
Yeah, it's not significantly much better in terms of the single iteration, and that's why I chose to put this, because to say that, well, they are at least comparable in the single iteration, but the main point is the preparation of the problem itself and launching of the software. But this needs to be actually, at some point I say that we need to do some, maybe I missed it in the slides, to do like statistical analysis to see if running this over and over to see if there is actually big improvement.
Any other question? Okay, so let's thank Mohammed again. He thinks on the robot is always really rewarding. Okay, who is next? Okay, so we have a coffee break. I don't. I have to check the agenda. I don't remember till when. Till 11. So I think that we can stick to it, right? So that we get back. So we have about 15 minutes. 15 minutes break. Okay. Okay. Guys, I wrote for somehow increasing the temperature of the room because it's too low. So since I received the shower, I have a really big.
Ma io ho anche la chiavetta, non posso chiavettare. Io vorrei anche chiavettare. Questo è il PC del. Ma questo è il PC di Dani? Questo cos'è? Questo l'ho messo qui dentro, secondo me. Vedi, io l'ho messo qua. Ma non è il PC? È il PC di Dani o no? No, PC a caso. Ok, allora se lo copio qui dentro sei a posto. Allora io lo copio qui dentro. Così? I have a pen drive. Oh, there is also this one, I don't know what it is. Okay, so if we all put everything on this laptop, we are like free, like all the next presentation will be ready.
Yeah, makes sense. That will, so how do I, like, in which format do I download this?
PDF. No, sorry, PowerPoint is fine because then here there is PowerPoint. Almost done. Power consumption. It's getting spoiling from the presentation.
Yeah, it's just like because I'm like this is the only presentation which is not robotic.
Still, it sounds interesting. I think more for like my personal interest than Iron Cup at the moment. One day it will be also probably not Iron Cup as soon as we will get the passion from the power.
So for connectivity, are you considering Wi-Fi?
Yes, but for projects that I have in mind, but they will never have time for them. It's interesting to read
Oh,
the
so
activity and transmit data over yeah.
so are you like interested in IoT and stuff like that?
Let's say yes, but like from a very naive perspective because I have no idea on how to do this kind of stuff. Let's say that I always thought about something like that for possible personal projects.
Yeah, there's a lot of open source stuff at the moment, so it's quite easy to look at something and deploy your own project. Especially new Raspberry Pis are really good.
I have only Arduino at the moment.
Which
But I
one?
think no, I think it's just a development kit, but it's very simple.
But the regular Arduino doesn't come with any Wi-Fi or comms too.
This one is for you, and no, I think no.
It's full time.
Yeah, it was from Humanoid. No, sorry. I opened this one instead of the other. Okay. This one. Okay. How can I turn on this switch? Yeah, don't worry, it's because of Windows. Continue now scanning. This one. And I move it in the folder. Ah, okay, it's done. You don't have so many videos in the presentation then, because mine was taking some time. Because I put the videos from the experiments.
I don't really have anything like this visual cues. So what is like super low level
Yeah,
development?
so it's difficult to show video. No, it's clear. This is the head of the stuff. I was just wondering how can we show it? Probably have to move it on the other screen. Or can I just mirror the screen here? Okay, now I'm here. So if I mirror the screen, maybe
Windows P.
okay.
You can do it very quickly like
Ah,
this.
duplicate. Okay. It was easier than expected. I always go I'm not a super Windows user. Okay. I always don't say.
Same thing on my Linux.
No, I'm curious to see if in the cloud people can see it.
Oh, I have
You have the yes. Let's see if you can connect. No, they cannot. So how do we share it from the cloud? Or I have to
sometimes if you do prison,
it's not going to be shared. No, but I think it's because this room is not in Teams. Oh, no, it is. So we are there.
we are wondering how to in a cloud actually.
So the room is on the cloud.
Yeah, the room is in the cloud, but then this one I think you should be able to use this code.
Is this the camera? No, this is not the camera.
Ah, the camera is there.
No, it's this one.
So what was you gonna put in the cloud? The station.
Yeah, this laptop. So we restored the previous setup.
Exactly. This is what we told you. I have to upload it.
Maybe we can ask Silvio if laptop selection.
Podium or smart podium, I don't know which one it is. Which is smart podium?
No,
Not like smart. HDMI, so that's correct. Yeah, that should be. No, we will see it. Yeah, we were just hoping to but we are seeing it. But we're also duplicating the screen, so maybe if it's like screen one and screen two.
but sorry, then it means that this guy is on team, and it is this one. No.
Sì, che come si share lo schermo. So qual è il trucco per fare sì.
Però,
No, no, ma questo è il computer quell'altro.
noi abbiamo le presentazioni sul computer.
Sì, noi abbiamo fatto le cose fatte bene, sono tutti gli altri che fanno dei danni. Ah, ok, I think I got it. So if we do extend and put this on monitor 2. Yeah, but you're not sharing with Teams.
No, you're not sharing on Teams.
Io spiego che sentiamo i altri che connect to the meeting and start.
No, yes, we can, but then we need our own laptop at this point. Okay, laptop selection is not, so I close it. Then, video conference,
Projection control.
video conference. No one is showing the video. Ok, ci siamo. Ok. Ma te ce facciamo il sharing del video. Content send. Content send. Per rompere non si rompe. Avete fatto dei danni incredibili. È venuto l'omino del... È venuto c'era l'omino di te che aveva sistemato tutto perfetto. Questa camera. Vabbè. Pip, cosa vuol dire pip? Io quel pip mi piace. Però questo qui è lo sharing con lo schermo grande. Eccolo. Ci stiamo provando da salvare. Perché è delicato. No, perché allora, staccato però non abbiamo fatto niente di terribile, spero. Purtroppo è una merda un po' delicata, ma come dire che le prime 2 volte va. A volte parte. Quindi c'eravamo vicini. Eravamo vicinissimi, eravamo. C'è già un computer, vuole che sì, ovviamente è una cosa che non si può fare, mettere una USB privata nel computer, ma non c'è soluzione. Vado a prendere qua ce n'è di... Qua c'è un... È di Humanoids. Era Humanoids. A volte va su Teams, ma non va in sala. But now on Teams we can see it, yes. So now, before it was the opposite, now it's this one. No, quella chiavetta qui la tengo molto con cura e la formatto anche, non c'è niente dentro. Adesso comprare tutti i laptop in cui non si tu? Sì, tutto io. Tutto io sto preso il potere. Ok, ci siamo. Ok. È fondato, ho messo anche il Teams, ok? Sì. No, 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 don't spoiler. No spoiler. Okay. Quando ritornate dalla pausa pranzo, dite sono di nuovo qua. This one, yes. Yes. You will have fun. Statistics time is about to come.
Perché fate un'ora di... Però alle 2 comunque ci vi serve il collegamento per non lasciamo no, non mi serve. Solo la mia. Chiudiamo mezzogiorno e mezza, ricordo prima, chiudiamo la registrazione, tutto sulla chiamata, e poi per la chiamata con le No, no, ma ho parlato con abbiamo fatto un meeting con Giulio e Mohamed.
Si vedono i miei video, però si vedono perfettamente.
Ok.
E l'altro dentro la tua giusto separati con la seconda.
Sì, penso sia qui, giusto?
Oddio, dove l'ho messa? Dentro la chiavetta?
Ah, la chiavetta ce l'ho tolto. Ah, magari dopo la carichi prima.
Sì, acabano di arrivare.
Non posso fare per tutti gli identificato se la giuria ti dice avanti, tu non è che guardi la cosa.
No, c'era una cosa lì.
Ah. Oh. Ok,
Ok.
okay. I think we can restart with 5 minutes late. Okay, now it's the turn of Gabriela.
Okay, so I'll try to be short. Okay, I will review as usual the Iron Cup team plan versus achieve milestone and statistics. And I start by with a overview of the research axis aerial humanoid robotics. Then I will talk about the main team activity during the research increment 10. Then milestone review, and then statistics conclude the presentation. Okay, so what are the motivation behind what we are doing? So on one end, let's focus on humanoid robots. They considerably improved their walking capabilities in the recent years, but still they struggle a lot, especially when they have to walk and move on the breeze or on soft terrains. On the other end, we have drones that are quite good at flying, but once they have to move inside a building in a very cluttered environment, they also struggled a lot, and it is difficult for them to operate efficiently. So the idea behind the research axis is to combine the best of both worlds in a single robotic platform, especially with the focus of operating on in case of disaster response. So ideally, the robot will be able to fly in order to move quickly towards like cover big distances over obstacles and other debris in the disaster area. And then, for example, enter a building and then switch from flying to walking,
and operate using contact locomotion, and so exploiting the cluttered environment for balance instead of everything is an obstacle for moving. So the objective is, in the end, is to increase the robot efficiency for disaster response and then pave the way also to new applications that can be designed for this platform. The team activities are very wide. They go from modeling estimation to control. We also focus on the hardware design and on the aerodynamics, thinking about the future where the robot will fly at higher speed. And yes, starting from these four main areas, we have all the activities that are carried out by the team. So the team is composed at the moment of nine people, including me, and the axis is structured following the lab rules. So we have the axis, then two components, iron cab and aerodynamics, and then all the elements, and also people supporting us from the technique for the ICAP tech and for management, and now also social media. Okay, so what happened in these last 3 months? So for what concerns dissemination, we resubmitted a paper to humanoids. It's Giuseppe's paper on trajectory optimization for transition maneuver between takeoff and landing and hovering. So there is this planner that allows the robot to take off and land. And also Fabio paper, the transaction of robotics paper that was already accepted from Fabio. It has also been accepted for presentation at IROS conference, so he will present the paper there. Then we also started rushes. So we started the rush iterations for the Iron Cab experiment. We are now at rush 5. So this is one of the main activity of the team was one of the main activity of the team in these 3 months. Okay, let's start reviewing the milestones. So overall, this is the level of completion of the research increment activities in these 3 months. That you see seems quite good, also compared to the previous one that we completed at 79%. Now it seems 84%. But I discovered that this statistic is biased because if you look closely, the total number of issues is less than in the previous research increment. And you say, why? I mean, this is cumulative, so the number of issues will always increase. It's because this works, this comparison works if you keep iterating over the same milestones. But if you are going to close milestone and remove from the list, or a milestone is just removed from the list because you are not interested in working on it during this research increment, then this statistic doesn't work very well. The correct statistic should be exactly after the research increment. So tomorrow I take the level of completion of the milestones of the increment, the starting one, and I compare it with the same value at the end of the 3 months. This is a statistic that will tell you if you add progresses in the research increment. And yes, if you are asking, the entire presentation will be about statistics. Okay, so now we move to a more reliable data. That is the data related to the single milestones. This is more reliable. And we start by reviewing the base estimation and FT modeling milestones. So we have several activities in the team, and I will review each activity by grouping them in macro area. So for base estimation and FT nonlinear modeling, we have 2 milestones. One is about extend FT sensor calibration model to nonlinear model, so to improve the modeling of our FT sensors. And the other one is about base pose estimation for flight. That is a big problem, and we are trying to achieve it in different ways. As you see, both activities moved on in this research increment. This time, I also put the total number of issues that are inside the milestone, because I think it's a good parameter to understand also how big and how difficult can be a task, and if there are progresses also in this sense. Okay, another big macro area that we focus on in the IronCAP team is jet engines modeling. For this, we have we try always to improve the modeling, the models of our jet engines and the thrust estimation, because we don't have direct measurements of the thrust while the robot is flying. There were two activities that were more related to improve simulations of jet engines in Gazebo, but we didn't really started them. And instead, we kept focusing on validation and refinement of the RPM-based Kalman filter for thrust estimation on the real robot. On this, we achieved good results. We managed to improve the accuracy of our test bench for the model generations of the turbine. Okay, then we have transition maneuvers, the one I said before, talking about the paper. So the objective here is to implement automatic takeoff and landing, and also transition between walking and flight. Prepare a publication of the vertical takeoff simulation. Yeah, it has been done, and the publication is submitted. While the other activities apparently are stale, but not really, because actually we are implementing this planner, at least a first version, on the controller, and testing on the experiments. So in this case, maybe the problem is that we should comment a couple of issues more. Okay, then jet engine. Sorry, I went back. Other activity is robust control. This one was previously carried out by Hussein, then Hussein left, and now there is Ebro, who joined the team for the summer. Here the idea is to, at least in simulation, try to improve the flight controller robustness, especially when we have bias or noise in the thrust estimation. And also she's working, like she's doing a great work on documentation. She's improving the IronCAP documentation for all the repos. And yeah, in fact, both activities are going on, and they have progress in this research increment. For what concerns the part related to aerodynamics, last research increment, we went to the wind tunnel and at Polimi, and we performed experiments there. And now Antonello is basically analyzing the data from the wind tunnel. And here you can see also the preliminary results. The curves follow, so it means that our simulations are not that far from the real data. And in fact, Antonello is still processing the data and analyzing them, but the activity is in progress. And then the second objective will be to use this information to reduce the gap between CFD and wind tunnel results. Then we are always related to wind tunnel. There is Fabio. So Fabio was working on automatization of CFD to CAD to CFD process. Now he's more focusing on the ISAC project. So for IronCAB, we just left one milestone, that is for the support of the wind tunnel activities. Yeah, here there was only one issue, but is not completed because soon in November, actually, again at the same day of the Unavatar finals, we will have an experiment at the wind tunnel. So Fabio supporting for the preparation necessary for this experiment. Okay, then we have morphing covers. This is another activity more related to the aerodynamics part. Basically, the idea is to design and model morphing covers that can adapt according to the aerodynamic forces acting on the robot. And here, now the focus is mainly on the development of the control and the simulation for the dynamic simulator. And yeah, the activity for the control part is a bit stale, but it's because the activity on the dynamic simulation is growing. So you see a negative number, but this is one of the cases in which it's because the number of issues is increasing, because we had some issues with the dynamic simulator, and we are trying to improve it and have a robust simulator to be used. And then later on, there will be the selection of the motors for the first prototype, for the first actual prototype of the morphing cover. For what concern then more experiments related activity, we have hardware design. It's a big activity for IronCAP because it includes both improvements on the robot and on the experiment layout. And in fact, these are the milestones. So there is the design of a new version of IronCAP MK2, and then improvement on the safety valve, batteries, and also the hardware used for the experiment. The hardware used for the experiment, we work a lot on it, and actually there are also a lot of issues in this milestone. While for MK2, the situation is a bit stale, is also because we asked an external supplier to produce the tank, and they are delaying, so we have to wait for them. We are pinging, but we have to wait. And then there was an activity related to the design of the new jetpack. We had ideas, and now I think these ideas can be tested, so we decided to close the milestone, and we will open a new one later on. Okay, for what concerns the experiment, we have the first flight and second wind tunnel campaign at Polimi. For the first flight, you see that is one of the main activity of the team. In fact, this milestone has 377 issues inside, and it improved, I think, also because of the rush. So we moved on this. And also the wind tunnel campaign organization is ongoing. Here you can also see a video of a very sleepy IronCAP that it is trying to stabilize the orientation. So the robot, the thrust is high, but not enough to over. But we are trying to test the orientation control and see if it can keep the desired orientation. And it seems that the results are promising. Now the robot is about to be repaired completely because it had issues, and then we will keep on the testing on this part. Okay, to quickly recap about the milestones, this is the, again, positive trend versus negative trend, more experiment-related milestone versus individual, more or less is similar to the previous research increment. Stale or negative trend is increasing for the individual milestone, I think maybe due to the rush, because if you're in the rush for the experiment, you spend a bit less time on your personal research milestone. Okay, statistics, and then I'm done. So the number of issues, like the flow of issues, decreased in this period. I think is because we are working on the sprint, but we are also focusing on problems that were there since a while, so issues were already opened, and we are closing them. So overall, the number of issues decreased in this period. And this is confirmed by the fact that the number of closed issues is bigger than in the previous research increment. And also, but still comparable. And also by the control chart, because as you see, the average of complexion of the issues increased. But I think that there are much more outliers than in the previous research increment. This means that we are closing issues that are there since a while. And also, there are a lot of issues that are below the average, so it's a bit biased by these issues. For what concern the bore down reports, they are not bad. More or less, we always close the same number of history point. That is about 40 per 2 weeks. And the number of issues we close in 2 weeks is about 15 issues in 2 weeks. And this is the last comparison. So here you see the research increment level of completion of the issues is about 58%. I saw that also ErgoCab, for example, have very similar statistics. So probably we always tend to overestimate a bit the number of issues in a single research increment, because more or less in the end we reach 50 to 60% of them. Okay, that was my presentation.
Any question for Gabri? I actually have a little bit of announcement. So the first one is a question. So
Okay.
concerning the jetpack, no, first the announcement. Sorry. So after the finals, when the ICAP 3 comes back, most likely we will move to the Iron Cub team, the ICAP 3. So this is what I wanted to tell you. So what does it mean? Does do the other teams somehow are without the robots? No, because we have the Ergo Cub coming. So the Ergo Cub robot, which is taller and somehow should be much better for physical human-robot collaboration. Actually, it's designed for that, and also for teleexistence applications. Now we have to see how to deal with that, but we are going to move to the Ergo Cub, and then most likely we will start making a plan for making the ICAP 3 fly. And this is supposed to solve a lot of the issues with, that are creating pain for the Iron Cub, which are of the cables of the shoulders. So we are currently actually these days having a complete maintenance opening up of the chest and upper body of Iron Cub because it was full of
Rust and
whatever,
other
whatever.
Giacomo said he never saw something similar until now, so I think it was not so good.
Yeah, Tech is doing a great job. So actually, then the question. So concerning the second version of the jetpack, so I don't know if actually it makes sense to invest on the Iron Cub V.1 rather than V.3 or V.2.
Yes, I think we have two versions here. One is just the same jetpack, but with the possibility to remove some part so that it will be easier to access the cables of the tendons in case the robot breaks the tendons, and we don't have to remove the jetpack every time. This one, I think it can be done. The other version, that is the one Punit is testing with increased wingspan and so on, at this point can be already on a future.
Okay.
Like we
Iron
plan it
Cub.
for ICAP. Yes, not for the 2.5.
Okay, and then I want to also tell you that in the video that actually Gabri showed, the robot did not, the robot did not move. So it seems that it was doing nothing. But actually, if yesterday we were just discussing that if you just put close by the same exact experiment without joint control, then the robot starts oscillating. So if you control the attitude only by using jets, the robot starts oscillating. So actually, the arms do something, because you do not actually appreciate this if you don't have a metric of comparison. Okay, so any other points, questions? Okay, let's thank Gabri again. And then we move to the next vertical presentation, which is always by Gabri.
Still me. Okay.
Yes.
Yeah, meanwhile I change.
Thank you, Gabri. So, how do you close the loop for the orientation with the Samanios, with the real sense? Can you?
Yes. Yeah, I can hear you.
Okay. Okay, here. So I was wondering, how did you close the loop for the orientation with Samanios, the real sense, or
At the moment, we mainly rely on the waste MU because we had a look at it and it seems that the data that provides are the most reliable. But yeah, for example, talking to Nuno, he suggested that now we have strain true on the, we changed the FT of the R, now we have strain true, so we can also get information from that. It's, we will see.
Yeah, just watch out because the IMUs in the arms for the magnometer are going to mess up. The other thing that I actually wanted to say is that to everybody, especially Teleexistence and ErgoCab, so the Iron Cup guys team was able to increase the frequencies of the control loops. So now they are at 200 hertz. Okay, so it's going to be really, really important that we somehow increase the frequencies also on the ICAP3 because this is a benefit for the entire architecture, basically now for free. Okay, so it's really important. They also did statistics, time statistics, so the control loops with Simulink and the entire Baraka there. So they are within the time slot. Okay, so this is another important thing that also somehow Julia that start now to integrate the locomotion part with the sub team. It would be nice to somehow implement. I don't know, Gabby, if you want to mention something about this.
No, I think yeah, is as you said. And then we will with the help of Akame, we managed to check that actually we were respecting the desired frequency, and it seems yes. So it seems that the all data and Simulink can run at 200 hertz.
Up to 400, I guess.
Up to 400, yeah. Then for 400 we had other issues related to the MU, but then
yeah,
we will try to solve it.
Okay, so let's thank let's thank Gabri again.
Thank you.
Sorry,
guys.
sorry, I had the machinery working. So Gabri, now you can start it.
Okay, so now for the vertical presentation, I will present this, let's say, more side activity that I carry on when I have some time. And it is about fault detection and control. And I want to show you the preliminary results with IronCab. So, of course, for aerial systems, it is like having a proper algorithm for fault detection and control is of extreme importance because a faulty sensor or actuator can lead to catastrophic results. And actually, looking at the literature, there are a lot of fault control strategies for airplanes, for spacecraft, but even for small quadrotors, like under-actuated quadrotors, and they work pretty well. So here the quadrotor in the video here has 2 broken propellers and still can fly and maintain the attitude. So the question that I wanted to answer was, okay, then we have IronCab that is, I hope, almost about to fly. So can the IronCab control recover in case there is an actuation fault? Okay, then there are a lot of type of failures that can occur, and some of them are catastrophic, and I don't think there is possibility to recover. For example, if the robot switch off, I think is done, is dead. Then there may be a joint hardware fault, and this may be recoverable, but I don't know. And then a turbine can shuts down. And this occurred very often during the experiment because there are several reasons that for which a turbine can shut down. For example, bubble in the fuel line, or overheat, or something enters in the front part and it damages the shaft. So there are several reasons. So I decided to narrow the focus, and I tried to answer to the question: can IronCab control recover if I lose one of the turbine during flight? To answer the question, I start looking at the IronCab control architecture. Here there is a simplified representation. There is a reference generator that generates desired center of mass position, attitude, and joint references. Then there is the core of the flight control that is a momentum-based flight control that outputs reference thrust, rate of change, and the joint velocities that are then stabilized by a jet control and an inverse dynamics control. This is the version implemented in simulation, at least, that outputs the final control input for the robot. Focusing on the flight control, in a very simple schematic, a very simple description of it is we write it as an optimization problem in which there are two main tasks. One is the stabilization of the desired momentum, linear and angular momentum of the system, and the other is a postural task to maintain a desired posture during flight, subject to some constraints. If you look at the momentum task, that is the one that is related to the flight stability, the momentum task has 6 dimensions, and our control input are the thrust, rate of change, and the joint velocities that are 4 plus 23 inputs. So theoretically, there is actuation redundancy. This means that theoretically, the flight control may be able to find a solution even in case to stabilize the momentum and so the flight, even in case there is a failure of one turbine. So I tried and I tested it in simulation, and what happened is that no, okay, the robot immediately falls down as soon as I shut one turbine off. The obvious reason is that the controller is not aware of the fault, so it keeps asking for thrust, to the thrust of the faulty turbine to increase. So at least I need to implement a fault detection algorithm. Since we use jet engines, one of the most reliable, the more reliable information from the jet engine are the RPM. So I decided to implement a fault detection based on RPM error. And it's a very simple one, so I simply check the RPM error, and if it is higher than a certain threshold, then fault is detected. As you see in the plots, it takes few seconds to detect the fault, and there are 2 states. One is when failure is detected, but turbines, the thrust is still above the idle, so turbines didn't shut off. And then when the thrust goes below the idle, the turbine is off. So I have implemented this fault detection, plugged it into the controller, and also performed the weights scheduling, in particular on the weights of the momentum task. And apparently it seems that this time it is working, but then looking closely, the joints keep moving, they don't stabilize, and then after some time, bad things start to happen. So the robots start to move, and if we wait still a bit more, it will fall down again. So close, but didn't work. Then I went through the data of the simulation, and I discovered that the reason, the main reason why there is this behavior is that the oscillations are due to the integral term of the inverse dynamics controller that doesn't go to 0 but keeps oscillating. And the reason is that the velocity reference from the momentum controller doesn't go to 0, doesn't converge. And why? Because there are a lot of joints that in the new configuration after the fault keeps hitting the limit. So my feeling was, okay, the robot found a new configuration for the flight with 3 turbines, but this configuration is not very stable, and the stability margin, the robustness of this new configuration of the controller are reduced, and these things can occur. So what I did is, okay, let's try to provide better references for the robot, especially for the joints and the attitude of the robot. And I've implemented this offline reference generator that can calculate references for the joint, for the robot configuration and for the attitude in case of a faulty turbine. So it is again an optimization problem over the robot attitude, roll PCO, the joint position, and the thrust. The objective is to find a configuration close to the initial one, such that the momentum derivative is equal to 0. So with 3 turbines, I have a static balance, okay, of forces. And then there are also other tasks that I have added. One is to maximize the manipulability, the determinant of the manipulability ellipsoid of the momentum task, which this task mainly means asking the controller to find a solution that is far from singularity. So try to stay far from singular configurations while you are achieving the momentum task. And then since the offline reference generator was keep throwing solutions that were with the links that were self-colliding, I had to implement also a self-collision avoidance constraint. And the simpler one was to approximate all the links with spheres and simply check that the distance between the center of the sphere. So the simplest algorithm that I could implement. And these are the results. So you see that it is able to find the 2 postures and attitude, one for the robot with one faulty arm and the other with a back turbine faulted. And then I plugged it in the controller. So this one has fault detection, weights scheduling, and after the failure, it updates the joints and the attitude references. And the problem is solved. So this time, the robot doesn't move anymore. The velocity converges to 0, and it can stay there. Now, it doesn't seem, I put clouds to show that actually time is passing by, so it's not stopped, but yeah, it's working. And then here you can see with a faulty back turbine, it goes in the new configuration that I showed you before from the optimization. And then the controller has also recovered its ability to move. So it cannot only hover, but it can also move, rotate, move forward, and stop before crashing into the house. Okay. And here you see the momentum, the error norm of the 2 main QP tasks. So the momentum error norm and the joints error norm. There is a big peak of error when the fault occurs, but then the controller is able to recover, and the error norm converges to 0, implying that the controller recovers its stability after the fault. Okay, so in the end, we answered the initial question. So with fault detection, weight scheduling, and updated references, the iron cap control can recover from the loss of one turbine, at least in simulation. Then there are possible improvements of this strategy. First of all, this controller doesn't handle the transient phase when I switch from 4 to 3 jets. So in that phase, bad things can happen. Sphere for collision avoidance worked, but they are a lot because I need a lot of sphere to approximate the links. Maybe with ellipsoids, it can be done something similar, and it will work. It will require less entities to approximate the links. And then I noted that the optimized legs can sometimes get very close to the exhaust flow. So adding jet cones constraint to avoid that the legs goes below the jets can be useful. And also in this configuration, it cannot land. It can get very close to the ground, and then we switch it off. So at least the the result will not be catastrophic as falling from 10 meters. But if I can add another constraint that keeps the leg parallel to the ground, then the robot potentially can also land after the failure occurred. Thank you.
Any question? Yes.
I wonder if the time slot in which the controller can recover from the attitude and be stable is comparable to a real jet failure. I mean, I was seeing like 5 seconds more or less. That's correct?
Yes, that's. I think it really depends on what happened on the real jet when a failure occurs. In the simulator, I switch off the failure in the jet in 0.7 seconds. Okay, assuming that there is a dynamics, so maybe the jet, as soon as there is a failure, the jet, also the real jet will not switch off like instantaneously, but there will be a small time for recovery. Then all the rest, so assuming that more or less that's correct, that's realistic, then I don't know if this performance that I achieved in simulation for the controller to react can be ported also on the real robot. It is possible that like the fault detector takes more time, or the simulator or the controller takes more time to react, so this has to be evaluated. I can say one thing, since the controller is in the end a torque control, the inverse dynamics controller implements torque limits. So this means, and the torque limits are the one of the robot, of the real ICAD. So it means that it cannot move the joints incredibly fast because it's in simulation. So there are limits that make it more realistic, but yeah, it has to be tested, I think.
Another question, sir. Are you planning also to investigate other failures?
Yes, there is another failure that it will be very interesting. That is if a shoulder joint, like the shoulder of the robot, fail, because you lose instantaneously. Like you have to shut off the turbine, otherwise you have like a moving mass, and it's not a good. Yeah, that's a big trouble. But yeah, I would like to investigate also that one. It's another, yeah, it's another. No, moving. No, I think those two are the most common failure that occur during our experiment. Either a tendon broke or a turbine shuts off.
I guess also the tendon can be everywhere in the leg or whatever. I guess. No?
Yeah, though shoulders break more often because subject to more effort. Any other question? Yes, Guillermo.
Yeah, thank you for the presentation. I just wanted to ask if the thrust limits in the simulation were actually bigger than the real one.
So the
maximum thrust available in simulation?
No, the thrust limits are the one of the real thrust.
Oh, okay.
The only difference is that, okay, in this version of the controller, there is no, despite I wrote it here, but this version doesn't have a proper jet control. So there is the thrust derivative, and then you, instead of the jet control, you just integrate the thrust, you just integrate the dot, and you send it to the simulator. So including the jet dynamics can make a difference, especially again on the reactiveness to the failure, but the thrust is in between the limits. And actually the offline optimization, yeah, you are right. I didn't write in the offline optimization. I forgot to add there are also the boundaries on the input. So thrust is in between the limit. Joints are in between the limit.
Okay, cool. Thank you.
You're welcome.
Any other question? So if you go back at slide 7, I just wanted to add one single thing here. So when you see things that seems to work, but then after a long time they do not work, this is technically called the instability of zero dynamics. Okay, so the output is 0, and then you have things that internally start moving. Here the output is basically the error on the center of mass. So I just wanted to add this technical detail. So technically speaking, this is instability of zero dynamics. Okay, so let's thank Gabriel again for this very nice presentation. Actually, it is the first time that we start including self-collision avoidance, which is something that for a long time we discussed about, but we never took this step. So it was really nice to see that we made it. Yeah, now we move to the next, which is Enrico, what I feel.
It's nice that we can control everything, but not the temperature in the room. It's great.
Yeah, I wrote it.
I think it's even worse now.
I can write it again.
Okay, let me remove this mask. I can breathe now. So I hope you hear me on the cloud. So now I'm trying to show you a little bit what we have done in the last 3 months for IFIL. So first of all, for the newcomers, what is IFIL? So the idea of IFIL was born around 3 years ago, more or less. The idea is to create wearable sensors to enable, let's say, many of the research activities that we do. So the idea is to create these wearables that are able to get real-time values of the motion of the people, and also some biometric sensors. So now we have temperature sensor, but we are not really using. But the plan is also to add ECG, EEG, or other type of sensor to get real-time data from the human body. Then we send this information to some algorithms. So basically we can, with the invest kinematic and other algorithms, we can get some human statistics, and we can also control the avatar, which can be a virtual avatar or a real avatar, like in our case, ICAP. And then we can also give back feedbacks to the human. And this is done through, at the moment, through haptic feedback. So, but in the future can be done also using temperature feedback and other type of feedback. So out of it, we decided some time ago to start, let's say, an idea of spin-off. So we investigated it a bit, we did some training, and finally we understood that there are many markets that can be, let's say, can be used for our activities, but then we decided to focus more in the healthcare. So we have a lot of activities going on in the healthcare environment. So just mention a couple of them, but we will see later on in the presentation. We have activities with the ISM, the multiple sclerosis in Genoa, other activities in Villa Beretta, which is a rehabilitation center in the north of Italy. And we are also applying to other possibility to monitor patients and to, let's say, to improve this part, to give some tools to the medical environment to analyze better the people. Okay, having said that, this is a list of milestones that we defined last time. We go through one by one. I'm not going to read them now. So the first one was for the IFIL, and this one is, these two are mainly for the spin-off. Okay, so the first one is what Gianluca is working on. I see a couple of videos here. So this is a video of the last insole calibration. So we had some issues related to some leakages of the air. So the idea here is to create a system that is capable to give a fixed pressure to the insole. There were leakages, so we did some tasks. So we put some new metal rings, and now here you see that everything is working. Yeah, now it's working fine. Still a few things to fix. So now we reach 1 bar. The idea is to reach 7 bar more or less, and so we have to increase this, but we have a really good starting point at the moment. Okay, then second milestone was to make a standalone graphical user interface for IFIL. So the idea is to be able to see what is happening in real time to the IFIL system, so the nodes and the shoes. And we did some tasks in order to reach the first, let's say, the first graphical interface. And you can see here we had the first test yesterday. Actually, it was very, very good to see because you can see real time all the nodes that are connected to the network, and you can see the data real time. Now we have to improve it a little bit. We have to maybe use some graphs or whatever, but we logs, so we have to improve it. Still, I would say 50% is done, but we are in the good shape. So I think it's good starting point. Okay, then we have to get the final version of the suit. So where we combine the multi-haptic and the nodes. Just to give Stefano a last second, because just got an email now, they deliver all the suits. So now tomorrow, but Monday we should receive all the set that we need for the final. So we have to check, and I hope they're fine. Okay, then this is a never-ending story. So I think it started a long time ago. So yeah, somebody has to read it and make comments, and then we go on with that. So for the moment, it's on hold. Let's see how we go on in the next research increment. Okay, then we have a very, very important, let's say, part of these activities because it's related to the stretchable insole, and this is something that everyone that sees is very interested on it. So we decided to do the second version of it. Gianluca is working on this task. And what you've done is designed a new version of the stretchable insole. We send it out for manufacturing. Actually, we got a quotation, so I don't know if we send it already out for manufacturing. But yeah, we finished with the design of this part of hardware. Together with that, we need to also design a new acquisition unit, so a new hardware for this acquisition. We are working on it. We delayed it a bit because we were quite busy, as Stefano was showing before, with a lot of demos in the last couple of months. So we delayed it a bit, some activities, but is ongoing. So I think we will reach good in the next research increment. We can finalize it. Okay, then we have also to investigate new dielectric materials because in this stretchable insoles require dielectrics to put on top to be able to use in normal shoes. And then not all the dielectrics are the same. Some are softer, some are harder, some are better. So we have to investigate. At the moment, we are investigating 3 of them, but we would like to buy more and try to understand a bit more about different type of materials we can use. So at the moment, we are on hold, but let's see if we can go on in the next research increment, or we put it on hold for a while. Okay, and then instead we have finished this new battery charger. So there is a new design here. On the left side, you see here the mock-up that we did in the design. It was not the real one. So we managed to assemble everything to integrate the electronics, and we tested. So now we have in the lab a different new version, which has some, probably you don't see it here. I don't know if this works. Yes, you see here there are some magnets that are capable to keep the modules one on top of the other. So we can charge multiple modules using only one power supply. Okay, then we have to create also some enclosure for the FUSE electronics. So some electronics that at the moment is not enclosure, so we can have troubles, we can break it. So we need to create some enclosure. This task was put on hold since the beginning, let's say, because some other priorities raised. So now we are planning to do it for the next research increment, also because we are going to the direction of certifying the shoes. So we need to make something more stable because we have to give to an external company. So then we don't want to risk to break them in just the first time they use it. Okay, then we have the first prototype of the ESB Wi-Fi bridge, which you will get some insight in the next presentation from Aditya. But just really quickly, what we wanted to do is to create a way to extend the range of the coverage range of the wireless communication between the nodes, so the suit and the shoes, and the PC. So the PC in this way could be, I don't want to say everywhere, but much farther away than it is now. Then you will get more insight later on. Okay, this again, you will get some more information later, but the idea is to use a certain library this was the initial idea to use this NINA library called to integrate this Wi-Fi module inside the iField system. Then we found out that there were better solutions, so we decided to quit this approach and move to a different one. So we can close this milestone, but it's not really done. Let's say it is investigated and changed. Okay, then we go to paperwork. So in order, just for everyone, in order to be able to go to do experiment with patient in hospital or in work environment, we need to pass through the ethical committee. Why this? Because our electronics is not certified. So we don't have any certification. So in order to go to patient, we have to be, let's say, safe and to be sure that what we are using is not dangerous for them. For that, there is a procedure. So we prepare all the, say, the documentation, and then we submit to the ethical committee. And they decide if we can go to the patient or not. So this is the first step. We did with the Multiple Sclerosis Association. They did it for us. We, of course, we had them for the documentation. We submitted, and now we are waiting for the response from the ethical committee. Same thing we have to do for Villa Beretta. So to be able to go to this patient in the rehabilitation center, we are working on it. We have a plan, so we didn't really start the activities, but it doesn't depend only on us, but we also depend on them. So we have a plan. The plan is to start the documentation on September, and then to do the clinical trials in November, so before the end of this year. Okay, this is one of the outcomes that we did from ISM, so the multiple sclerosis. So the idea was to implement some KPIs in order to give real values, real numbers to doctors, because they cannot really understand exactly what we do. So we had to give them KPIs in order to allow them to evaluate our investigation. So this was defined together with ISM, and Claudia took care of implementing some of them. We implemented 10 out of 15, but this is enough as a starting point. So we are going to give all this information, and we are going to apply these KPIs to all the activities that we will do, the clinical trials that we will do later in the next month and years, let's say. So we finished this milestone. Okay, this was a little bit aside related to iField. So it was using iField node into the PAEXO. So Marco managed to use the iField node. So at the beginning, the first iField node that was using was an old version and it was not really working properly. We decided to move it to the last version of the iField nodes that we are using in the shoes. And here you see some graph taking data, real-time data from the iField nodes using PAEXO. Okay, then we have, this is related to the CE marking of the shoes. The plan now we have, we would like to achieve a certain point. I mean, we cannot make a CE marking on the shoes because we cannot do as IIT, but the idea is to complete all the steps in order to be ready for the CE marking on the medical devices. For this, the procedure is very long. It takes like between 9 and 12 months, and the cost is very high, and say what we have to do is a lot of work and a lot of tests. This is a test called RED, which basically is the radio test of the electronics. We started these activities. It's still in the say initial stage, but the idea is to finalize it by the end of August, hopefully. Okay, then we decided also to start new activities to create a new version of the shoes, a lighter version, and a version that at the end would be able, let's say, people that will be able to create, I don't know, 1,000 units of the shoes, because at the moment is a little bit more done manually, but we would like to make it kind of industrial device. So we started with evaluation. We have to, with the quotation, we have to evaluate it, and then we go on with these activities. Same thing for the suit. Now we have say plan with Dario, Dario that is for the first time in this increment, to create an iField suit version 2.0, but this time will be wired. So we will create a suit with the wire integrated into the suit. This way we don't lose data, and we have a different approach of the data, so it could be very useful, let's say, to use. We started this activity. We start investigating the type of wires that we can use and we can put on the suit itself, and then we go on in the next few months. Okay, related to the spin-off, there were two milestones. The first one was to add new content to the LinkedIn post. We did a lot of posting actually related to all the tests that we did, the demos that we did in the past months. So Mr. First, for instance, the Amazon TV show, and all this. So you are, let's say, you are more than welcome to follow iFeel and to see all our posted and what we are doing. Then there is the milestone 2 is the organization of advisory board. This is very important to move on to the real startup. So basically the idea is to create a small team of people that don't belong to IT, but they are external people that can help us to let's say, follow the proper path and to give us some more information related to what the market needs in terms of outcome from iFeel. Okay, here just an overview of what has been done and what we still have to finish. Just a quick overview of this. Okay, this is not done. And here some statistics, which are not really fun in this case, to be honest, because it's difficult to compare. I mean, we cannot really compare iFeel statistics with Iron Cable. It's difficult because we do it in a different way. So I keep on doing as I was doing the last research increment, so I can compare what iFeel is doing in the years. Which I think is the best way to do it this way, unless we decide to do exactly the same altogether, but it's not so easy, my viewpoint. Okay, so activities are going on. I think we are in the same line on what we have done in the past research increment. The average is quite good. So nothing very strange. I don't see anything very strange. I would say here we are following a good path. Then of course, what normally happens that newcomers are arriving in the middle of the research increment. They put a lot of issues. Then you go down with what you have done. But it's not really that you go down, but it's just because you add more things that were not foreseen at the beginning. So for me, the trend is pretty good, I would say. Okay, so this is done. I really hope that you will follow the web page, the LinkedIn, if you can add to follow the LinkedIn for iFeel. And then, yeah, let's see how it goes on for the next few months. Let's see.
Okay, so let's thank Enrico. I just wanted to say that, yeah, probably, Claudio, you may mention directly that when you actually, there was the nice moment, because I was not there, when Jessica Podda from the Italian Association of Multiple Sclerosis actually was finding that the asymmetries was seen also in the patient. I don't know if you want to mention something about that for the asymmetry on the knee.
Yes, basically in the KPIs I developed, there is one for the pattern, for the gait pattern, for the lateral gait pattern. And I analyzed a subject, a trial, and I found something strange on the left part and something good, let's say, something normal, what I expected on the right part. 1 week ago, we had a meeting with Jessica Podda. Jessica Podda is a researcher in AISM who helped us for the ethical committee document, and he said that patient had a problem on the left knee. So that problem was not related to the pathology, to the multiple sclerosis, but it was good because our KPI was able to detect that problem even if not related to the pathology. So it was good for us. I mean, a good starting point, and I mean, these KPIs are really generic for the gait pattern in general, not only for the sclerosis.
Yeah, this means that in this way, we can give quantitative information to the medical environment, which at the moment you will be surprised to see that they don't have anything. They really look at the people and they understand that, oh, this is good, this is not good, is improving or not, but they don't really have quantitative data to analyze it. And it's surprising in my viewpoint, because I mean, we are into 2022 with a lot of technical things, and they don't have it, they don't use it. So.
Yeah, yeah, Connor.
Hello? Okay. I have two questions. What is real time to you guys? Like, what speed is real time communication?
Yeah, so you mean how fast we go with the acquisition, data acquisition. So now I think we reach 60 Hertz, more or less. We have a limit related to the IMUs because we are using fusion data directly from the IMUs. So one, say, path to follow could be to increase this in order to use not the fusion data, but to create our own fusion data, which could be faster. But now what we are doing, actually, we are trying, because this is a bottleneck at the end of the story. Yeah. So this is a bottleneck because it takes, just to give you an idea, 10 milliseconds more or less to get the data from the IMU. Mm-hmm. So this, when you add 20 sensors, you have a bottleneck like this. Yeah. What we are doing also in this direction is to use a different IMUs. So we have a new IMUs that Dario is using, we starting now, say, investigating. And then we really hope that it will be faster and we can go faster also.
Yeah, it's because I think Xsense is probably, if you talk about like competition for this technology, it's the only thing I've ever seen that's similar. Are you? I was sort of drifting off and thinking about things while you were presenting. But how much? Yeah, I understand you want to sell this as a sort of spinoff. Do you have an estimate on how much it would cost? Because I mean, I can tell you right now that in the research community, that just in academia, they pay a lot for this type of technology. So right now with Xsense, they can make estimates, but it's very difficult to use. You're constrained to a specific area. You're constrained to a set of software. So for people that might want to know.
Yeah, no, I mean, we know how much Xsense cost. That's we know. So I think the order of magnitude is not far away, I would say, because anyway, the cost itself, just to give you an idea, is a few K or so. Then if you have to add software, if you have to add all the infrastructure, and so the cost raise up for sure. We didn't do really an analysis on that. We did some, say, some preliminary analysis, let's call it like this, and so we know that the order more or less is that, because you have to take into account that we also have the shoes, which are very expensive. So the shoes are very expensive because the FT sensors are very expensive. This is the big issues that we have at the moment. So with the FT sensor, you can get a lot of data, very interesting, but then they cost a lot. That's why we decided also to go in the direction of the insoles, because the insoles are much cheaper. Then, of course, it's also difficult, let's say, to evaluate it, because if you have one device, it costs 100. If you have 100,000 devices, it costs 1. So you see what I mean? So we did, let's say, an evaluation, and we are also trying to understand what we want to sell, because it's not only the hardware. But the advantage, I would say, for this hardware is that it's flexible, first of all. Xsense at the moment is not flexible because you have to use a 17 sensor, you have to wear the person with 17 sensors. And when you go to the patient, to academia is fine, but when you go to the patient, when they have a lot of troubles, only half an hour to wear the people, they are already tired. You know, so after 10 minutes that they wear stuff like this, they get tired and they cannot really do the task anymore. This is an issue that we are trying to face using a smart suit or smart whatever, a t-shirt, whatever it will be. And then, yeah, we have this phase that we are trying to reach, but you know, the idea is more not cutting the cost on that, because I don't think it's feasible, but adding feature and give, let's say, more flexibility to people to be used as they want. It's more or less the idea.
Thank you.
Any other question? Okay, so I think we can thank Enrico again and move to the next question, next presentation by Aditya. So have you your own laptop? You moved the, okay. Is the cloud connected? You no, don't worry, keep the focus. Poi finta, cioè. Okay, so I don't know if the cloud is connected. And, but, okay. I think you can start, Aditya. Yeah.
Ah, right, perfect. All right, so I wanted to present my project, which is an ESB to Wi-Fi bridge for the Eiffel node. Ah, maybe better now. All right, so my project is an ESB to Wi-Fi bridge for the Eiffel nodes. And in this presentation, I want to go through the project milestones and basically whatever I'm doing at the moment, which are three main development axes. So initially, we have the hardware or system architecture, and then we have a driver library for the Wi-Fi modules, and finally, we have to determine a network architecture for the project. So that basically means how we get the data from our bridge to the computer. And yeah, so like I said, the goal is to basically design and deploy a Wi-Fi based node. So the station will be mounted on the suit and it will collect data from the nodes and stream the data over a Wi-Fi channel. The Wi-Fi channel is still yet to be determined. We are currently still working on the network. Sorry, we're still currently working on the system architecture. And yeah, let's take a look at the current system. So the current system has a bunch of Eiffel nodes mounted on the suit, and all these nodes individually report their data to a station with a protocol called ESB, Enhanced Sock Burst, which is a proprietary Nordic protocol. And it uses the IEEE 802.15 radio, so the range is not super big. The range is maybe around 2 meters. And then the station is connected to a computer with USB cable, and that's how we get the data from the Eiffel suit to a PC. And yeah, why is this not super good? So sure, yeah, we have low range. We have a bunch of packet drops because of obstacles and orientation issues. So that's another problem if the orientation between the node and the station is changed, it's not direct, we get more packet losses. And we tried to kind of rectify it with some passive antennas, and the results were a bit underwhelming, I'd say. And yeah, another issue is that we can have only one receiver. So all of the data coming from the Eiffel nodes can be only received on one pipeline. So it's not like we can put the suit on someone and then receive the data on multiple computers simultaneously. So moving on, then we have our proposed system, which I believe would be great, which I think we all believe would be great. Here, the idea is that we put a ghost node on the suit. A ghost node in the sense that it will look pretty much like an Eiffel node, except we don't have the sensors or we don't have the actuators. Instead, we put an Wi-Fi module on it. And we still use the proprietary protocol, enhanced sock burst, to report the data into the station. And then the station has the Wi-Fi module. So with that Wi-Fi module, we are able to stream the data on a computer. That pipeline is not yet defined, so we can have a point-to-point communication. We can send the data over internet. And yeah, so why do we want to use Wi-Fi? First off, we have much bigger range. We have less latency with less packet losses. And yeah, of course, the possibility to transmit data over internet. So you are not essentially limited to the range of the Wi-Fi, but you can use Wi-Fi to just put the data on a cloud. And as long as your computer is connected to the cloud, you can access the data from essentially anywhere in the world. But of course, it comes at the cost of higher power consumption. But I also assume that because this host node will not have the actuator or the sensors, we may not be losing out on so much. So at the current project outline and development goals, so the first thing is to add Wi-Fi functionality into our project. Um, that consists of getting a Wi-Fi module, getting a corresponding library for the Wi-Fi module, and use the library to interface the microcontroller with our Wi-Fi module. So once we have developed that and we have implemented a Wi-Fi functionality on our microcontroller, we can move on to the next part, that is the microcontroller to PC pipeline. So how do we send the data from the station to the PC with um, so that includes our network architecture. We can figure out that later. I would imagine a socket would be a pretty elegant solution. And well, once we are able to send data from our microcontroller to the PC over a pipeline, we have to integrate our current station code, the current station code that still collects data from all of the nodes with ESB with a schedule. And yeah, when we have that, we should keep in mind that we are still developing this on a development kit. So this is a whole prototype situation. So once we have a properly working prototype of the whole thing, we port it to a custom board and turn it into a ghost node, essentially, and which can be mounted on the suit. It can collect data from all of the nodes and transmit the data over Wi-Fi. So yeah, let's discuss the challenges of the development progresses. The microcontroller we were using, the Nordic NRF52840, it has essentially zero support for Wi-Fi, which is a bit underwhelming because like a couple of years ago, they acquired the company that specializes on Wi-Fi products. But we have checked with Nordic and they have no Wi-Fi functionality and have no plans to add any Wi-Fi functionality. This is an accurate representation of, I guess, the Nordic engineers out there. So to add Wi-Fi functionality, we wanted to select a Wi-Fi module and integrate the Wi-Fi module into our project. We looked at some possible options and we decided on this Wi-Fi module. This is an Atwin C1500 network controller, and I think it has quite good power consumption ratings and range specifications as for our requirement. And so we have the module and then we integrate the module with um, a generic library. So once we have that, we have implemented the Wi-Fi functionality on our project.